So we've been graphing quadratic equations. We first started with absolute value functions. Now we're doing quadratic functions. We graphed what's called the vertex form, where I find the vertex and I have the equation y is equal to a times x minus h quantity squared plus k, where h and k was the coordinate of my vertex. Here's the thing. There's other forms of a quadratic equation that I can graph. I just don't have just one form. I have multiple forms. Just like when we were talking about linear equations, I had y equals mx plus b. I also had point slope form y minus y1 is equal to m times x minus x1. I had standard form ax plus by is equal to c. These are all linear equations. Today we're going to talk about another way of graphing an inequality. How about a quadratic equation? We've done vertex form. Today we're going to talk about what is called intercept form. I'm going to find my x-intercepts, and from my x-intercepts I can write an equation. So let's see how this works. So like I said, this is on course pack page 505. Course pack page 505. I haven't said that yet. So please go ahead, get that out, pause now, and the notes are on course pack page 505. Intercept form. First of all, the form of the equation is y equals a times x minus p, x minus q. Just like with the h, the p and the q are what's opposite of what's inside. So if it's a -2, p is 2. If it's a plus 5, q is -5. So the x-intercepts are the coordinates p, 0, and q, 0. The axis of symmetry is halfway between these points. So x is equal to p plus q divided by 2, the average of p and q. The parabola opens up if a is positive and opens down if a is negative. So when I'm graphing intercept form, I just need to graph 3 points. Which 3 points? I need to graph my 2 intercepts, p0 and q0, and my vertex, which I get from the line of symmetry p plus q divided by 2. Let's do some of these and see how that works. So here we go. Example 1. Y equals -x plus 2 times x minus 4. What is p? What is q? Well, again, I want the opposite of here. So plus 2 tells me that p is -2. Minus 4, opposite tells me that q is 4. So I have the coordinate -2, 0, and 4, 0. So -2, 0 on my graph is here. 4, 0 on my graph is here. I know that since a is negative, my parabola is going to be opening down. I know that my domain is x is going to be an element of all real numbers. My range is going to be y is less than or equal to whatever my y coordinate is. But I need to find that vertex. And to find my vertex, I have to find the middle of these two numbers. And I can do it graphically or I can do it algebraically. Algebraically, I'm going to say p plus q divided by 2. So I'm going to say -2 plus 4 divided by 2 is 2 over 2, which is 1. So that tells me that x is equal to 1. That is my axis of symmetry. Okay, and notice my 2 intercepts are equidistant, the same distance. This here has a distance of 3, and this is a distance of 3. So that is my line of symmetry. So I know my vertex is somewhere on this axis of symmetry. Where is it? Well, plug x equals 1 into my equation. So I'm going to say that y is equal to negative 1 plus 2, 1 minus 4. So y is equal to negative 3 times negative 3. So y is equal to positive 9. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. I know my vertex has to be on my axis of symmetry. My y-coordinate is 9, so I have the coordinate 1, 9 is my vertex. Here is my graph. Let's fix that one leg. I always do well on one, and the other one always gets a little off. Just as if I would do this the other way, I can check this. I can go out 1, down 1, out 1, down 1, 2, 3, out 1, down 1, 2, 3, 4, 5, out 1, down 1, out 1, down 1, 2, 3, out 1, down 1, 2, 3, 4, 5. I still end up with the same graph even if I use my other method of coming up with the points. So I have my 3 coordinates that I need. I needed the 2 x-intercepts, and I needed my vertex. Those are the 3 points I needed a graph. Did I come up with 2 others here? Or actually 4 others here? Sure. But I only needed 3 when it comes to graphing this using intercept forms, my x-intercepts and my vertex. What is my domain and range? My domain, x is an element of all real numbers that never changes. My range is y. Since it's a negative equation, is less than or equal to my y coordinate, which is 9. So there's my graph. I have my graph. Let's try another one. Let's see what the next one looks like. Example 1, part B, graph y equals 2x minus 3x plus 1. A is positive, so this is going to face up. I need to find P and Q. P, I want the opposite of this is 3. Q, I want the opposite of this, so this is negative 1. So I have the 2 coordinates of 3, 0, and negative 1, 0. I can plot those 2 x-intercepts, 3, 0, and negative 1, 0. I need to find my vertex. I need to find my axis of symmetry. So I'm going to add P and Q and divide by 2. So 3 plus a negative 1 divided by 2 is 2 over 2, which is 1. Is it always going to be 1? No, but for these 2 problems, it turns out to be 1. So my axis of symmetry, this happens to, again, be x equals 1. I now need to find what y is when x is 1. So I'm going to say that y is equal to 2 times 1 minus 3 times 1 plus 1. So 2 times negative 2 times positive 2. 2 times 2 times 2 is 8, so this is negative 8. So I have the coordinate of 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 1, negative 8. And my parabola is going to look like that. I've got my 2 intercepts. I have my vertex. What's my domain? My domain, again, is x is an element of all real numbers. My range, y, since this is facing up, is greater than or equal to my y coordinate, negative 8. There's my graph. If I wanted to, could I use that special little motion that we did? Sure. Remember, it's out 1. Since it's times 2, it's up 2. Out 1, up 1, 2, 3, 4, 5, 6. Out 1, up 2, since A is 2, out 1, up 6. I still get the same points. I get extra points, but I still get the same points. It still works. I can still graph this using intercepts versus vertex. I have to find my two intercepts, and I have to find my vertex. Let's do another graph. This is letter C. Negative 1/2 x minus 6 times x minus 8. Again, P is the opposite of this, is 6. Q is the opposite of this, so that's 8. So I have 6, 8. That's a lie. 6, 0, and 8, 0. There's 6, 0, 8, and 0. This is facing down. Since A is negative, it's going to be wider. Since A is between 0 and 1, the absolute value of A is between 0 and 1. I need to find my axis of symmetry. So x is equal to P plus Q divided by 2. That's 6 plus 8 divided by 2. So that's 14 divided by 2, which is 7. So my axis of symmetry doesn't always have to be 1. Here, it's 7. I have to find the other part of my coordinate. It's 7 what? So I come up here and say y is equal to negative 1/2 times 7 minus 6 times 7 minus 8. So this is equal to negative 1/2. 7 times 6 is 1. 7 minus 8 is negative 1. 1/2 times 1 times negative 1, that's a negative 1/2 times 1 times negative 1, is positive 1/2. So I have the coordinate 7, 1/2. Here is that coordinate. Here is my parabola. My axis symmetry was x equals 7. What's my domain? Again, domain, x is an element of all real numbers. Range, y, since it's a negative a, is less than or equal to the y coordinate, which is 1/2. There's my graph. Let's try another. Letter D. Now you're going to look at this and you go, wait, I need to find P and Q. P equals Q equals. But wait, I don't get this. There's nothing that's added in here. Well, remember, I could always rewrite this as x minus 0 times x minus 4. So if there is no P or no Q, I can always assume it to be 0. And the opposite of this is 4. So I end up with the point 0, 0 and the point 4, 0. Those are my two intercepts, 0, 0 and 4, 0. I need to find my axis of symmetry, so x is equal to P plus Q divided by 2. 0 plus 4 divided by 2 is 4 over 2, which is 2. So my axis of symmetry is x is equal to 2. Okay, what is my y coordinate? Y is equal to 2 times my x coordinate we've already said is 2. So this is 2 times 2 minus 4. 2 times 2 is 4. 2 minus 4 is negative 2, so this is negative 8. 2, negative 8. Because A is positive, 2, this graph should be going up. I have my axis of symmetry. I have my 3 coordinates, my vertex, and my 2 intercepts. I need my domain and my range. My domain, x is an element of all real numbers. I can pick any x. My range, y, since A is positive, it's greater than or equal to my y coordinate, which is negative 8. All the y's it gives me are going to be above negative 8. It won't ever give me a y that's less than negative 8 because that's my vertex. That's graphing these. What if I give you a graph and you have to come up with the equation? Well, let's look at this. Here's a graph. Run an equation in intercept form for the following parabola. You're looking for three things. I'm looking for my two intercepts and a third point. So my x-intercepts are the coordinate -2, 0, which is this one, and the coordinate 3, 0, which is this one. The other given point is the point -1, 2. So let's find this equation. Right away, I can say that y is equal to a times x minus p, x minus q. I know that p is -2 and q is 3. So y is equal to a times x minus a -2 is plus 2. X minus 3 is x minus 3. There's my equation, but I need to plug in something for a. So I can write up here y equals space x plus 2, x minus 3, and now I have to find my a. Well, the good thing is I'm given this point -1, 2, where -1 is x, 2 is y. So 2 is equal to a times x, which is -1 plus 2, times x, which is -1 minus 3. 2 is equal to a times -1 plus 2 is 1. -1 minus 3 is -4. So 2 is equal to -4 times a. Divide both sides by a -4. I get a is equal to -1/2. Wait, a equals -1/2? Well, my graph is facing down. So a should be a negative number. It makes logical sense that a would be a negative number since my graph is facing down. My domain, x is an element of all real numbers. My range, y is less than or equal to, since it's facing down, my y coordinate of my vertex. So y coordinate of my vertex was, well, I never found my vertex. So at this point, I'm not going to worry about it too much. Could I find it? Yeah. It's halfway between these two. It looks like it's going to be 0.5 and a little more than 3. I'm not going to take the time to find it because I already have my equation, but I could find it if I needed to. There's my equation. That's how I find an equation given the graph. Have a good evening.